Hello, my name is Valeria, and today I'm going to be talking about airspeed indicators. The reason why I chose this topic was because my first choice was taken, and this sounded like a good alternative. Now I present to you the airspeed indicator. It calls the cockpit its home, and if you know anything about cockpits, is that there are a lot of different things on them, and there are a lot of different ones. And honestly, when you look at one for the first time, it's definitely overwhelming. But hopefully by the end of this video, you'll be able to identify this bad boy anywhere and have one less thing to worry about in your career, as well as maybe have a few fun facts to throw out during parties. I don't know, maybe your parties are cooler than mine. So let's start at the beginning. What is an airspeed indicator? Well, according to Chapter 4 in the Glider Flying Handbook, you can find through the FAA webpage, the airspeed indicator measures the difference between the pilot pressure and static pressure, and that displays the difference as the indicated airspeed, or IAS, of the glider. If you didn't understand that at all, well, neither could I. So my job here is to try to explain it, put it in normal human terms for us. The airspeed indicator is an instrument that displays the measured speed at which your aircraft is moving through the air. It is an FAA required instrument because it helps to guide you during climbs, descents, and landings. And although everything in the cockpit is important, this one's good to pay attention to because without sufficient airspeed, your baby will not fly. The airspeed indicator receives pressure info from two different sources, and after calculating the difference, it presents the data to you as airspeed. Now, on a more technical tangent, the airspeed indicator is a calibrated barometer. If you don't know what that is, don't worry, I didn't either. A barometer is a scientific instrument that measures air pressure, and this baby just happens to be calibrated, and instead of the data being called pressure, it's just known as airspeed. So, how does it work? Unlike a car, there are a few more factors at play here, like the wind and air density, as well as all the errors that can occur to the instrument itself. An airspeed indicator is connected through the static line to something called the pilot static system, which is a network of hollow tubes that let the air flow in and out of different instruments. Now, our mighty network when it comes to the airspeed indicator itself consists of, drumroll please, two feeds: the pilot system and the static system. The pilot system measures dynamic pressure, also known as dynamic air, and also sometimes called ram air. Meanwhile, the static system measures static air, which is literally just air at rest, ambient air, and if you will, the room temperature of air, which is essential to measuring the dynamic pressure correctly. The static port is usually placed in an area of relatively undisturbed airflow, such as the side of an aircraft or on the side of the fuselage that is parallel to the airstream. That is usually a common place in, but to be honest, it could even be in the cockpit. Meanwhile, the pitot tube is usually on the wing and is set perpendicular to the airstream. That way, it allows it to capture the total air pressure being generated by the plane as it moves through the air. It is also important to note that sometimes your airspeed indicator will not work, and that's usually caused by either your static ports getting clogged or your pilot tube getting clogged. There are a lot of scenarios, but the most likely one is your static port being iced over. But as I mentioned before, the opposite is also likely, having your pilot tube clogged, meanwhile your static tube is open. And honestly, you can have both of them clogged, or one could also just be partially clogged. The point is that it's important for you to check over and make sure they're not clogged. If you are in icing conditions, you can use your pilot heat, which is an anti-icing system that warms the pilot tube to make sure that they don't ice over. And it's critical that even before you leave the ground, you make sure that they're not clogged. Because if you're not getting the proper information of your airspeed, you're most likely not even going to be able to leave the ground. Finally, I'd like to tell you all how to read this overcomplicated arithmetic tool. Quite ironically, it's simple. Around the dial, you will see that your needle will point you to a number. This number is your airspeed and it's measured in knots, which are nautical miles per hour. You will also notice that there are different bands of color. There's a white one that overlaps with a green one, a yellow one, and a tiny strip of red. These are called B-speeds, and there are plenty of them, but that's another can of worms to open. For now, the general consensus is that each color represents an operating range. The white one is your normal flap operating range. At the bottom of the band, so the smaller numbers, that's your stall speed in which your flaps and all your gear is extended. Meanwhile, at the top of the band, which is the bigger numbers, there's the maximum speed in which you can have your flaps extended without them just ripping off. The green one is your normal operating range, usually where you want to stick to. At the bottom, that's your stall speed in clean configuration, so your safety area. And towards the top of the band, that's the maximum cruise speed. When you go into the yellow, that's your speed caution range. You just want to really maneuver with care all throughout the band. And then there's the red line. The reason why it's just a line is because you never want to exceed this speed. It is a speed that adds excessive structural load to your airframe and will just destroy it. Obviously, I can't tell you exactly what happens because I don't know, but rest assured neither you nor I want to find out, so let's stay away from the red. Red is stop. So in conclusion, the airspeed indicator is an instrument that displays the speed in which you're going through by measuring your dynamic air through your pitot system and your static air through your static system, then taking both of those numbers, subtracting it, and giving you your airspeed. Once you have your airspeed, you can go through climbs, descents, and landings safely, as well as being able to visualize meanwhile you're flying what range the speed you're going at lands in. The green one being good, the yellow one being somewhere you want to be cautious in and not wanting to pass by the red. I hope that now you know what an airspeed indicator is, how it works, and that when you're in a class where they have to teach you what an airspeed indicator is, you can smirk to yourself and be like, I already know this. Thank you.